In this video, we will consider the control chart for attributes. By attributes, we mean the status of a product, either it is good or defective and all. And we have two types of control charts in this case of attributes. One is counting the proportion of defectives or number of defectives, and the other is number of defects in a unit area of the product. So first we will consider this control chart for number of defectives or proportion of defectives. And we have the two charts, P chart and second NP chart or D chart. P chart gives the control chart based upon proportion of defectives, and the NP chart gives the control chart for number of defectives. Now, first we take P chart. In this P chart, we consider some samples drawn from the product, and at the end point, we classify them as good or defective. Suppose the samples are drawn in subgroups, the number of units in subgroup may be equal or unequal. And we have Di is the number of defectives in each subgroup, and Ni is the number of items selected in each subgroup. Therefore, the sample proportion is Pi is equal to Di by Ni, and I is equal to 1, 2, 3, etc. K, where K is the total number of subgroups. Now we consider the central line as P bar. P bar is equal to total number of defectives obtained in all subgroups divided by total number of products inspected. That is, P bar equals total number of defectives divided by total number of products inspected. And the UCL and LCL are given by P bar plus 3 root of P bar Q bar by N and P bar minus 3 root of P bar Q bar by N, where Q bar is 1 minus P bar. And here N is the size of the sample if all samples are of equal size. If all subgroups are of equal size, we take N is the size of each subgroup. And suppose the subgroups are not with equal size, say N1, N2, etc., Nk, then N is taken as average of these subgroup sizes, that is N1 plus N2 plus etc. plus Nk divided by K. Now the sample proportion values Pi's are plotted on this graph against each subgroup number, and if all sample proportions lie within the UCL and LCL, we say the product is production process is under control. Here the principle of this control chart, that is P chart, is actually based upon a relation connecting binomial distribution and normal distribution. We have found that X representing the number of defectives or number of successes, then we get X follows BNP, that is number of success distribution is addressed by binomial distribution, that is X follows BNP. Again, we have found that when n tends to infinity, we get Z equals X minus NP divided by root NPQ. Root NPQ follows N01. This is possible when n tends to infinity. N01. This is possible when n tends to infinity. So if you divide this throughout with n, it becomes x by n minus p divided by root of pq by n. Pq by n. And this principle already we considered in testing of proportion has a specified value, equality of proportion, and many occasions. So this is the main thread of constructing the control charts for proportion, that is P. This x by n is taken as the sample proportion, so that has normal distribution. That's why we have the control chart, control lines p bar minus 3 root of p bar q bar by n and p bar plus 3 root of p bar q bar by n. The 3 is to get the 3 sigma limits. So it is actually in the structure of mu plus or minus 3 sigma limits. That's about this control chart for P. Now we have one example. We have sample numbers 1 to 16 and the sample of number of units in each sample or subgroup displayed in the second row 48, 36, etc. And number of defectives in each subgroup in the third row. Here we note that the number of units in each subgroup uh, are unequal. Okay, the number of units are unequal 48, 36, etc. Now we have this table calculating the proportion of defectives in each subgroup. So it is 48 number of items inspected and number of defectives 5. So this is 5 by 48. This is 5 by 36, that is 0.139, 5 by 36, 0 by 50, etc. So this column represents the proportion of defectives in each subgroup, that is P1, P2, P3, etc. Pk. Now P bar is total number of defectives. We can get the total of this column, the third column, and the total number of products examined. The total of the second column, that is 36 by 720, 0.05. Now, since the sample sizes are unequal, we calculate average sample size, that is 720 divided by 60. Total number of units examined is 720 and number of subgroups is 16, so 45. So these are the control lines, p bar minus 3 root of p bar q bar by n and p bar plus 3 root of p bar q bar by n. Substitute all these values, we get UCL equal to 0.14747 and LCL is minus 0.4747. This is P chart or the proportion related chart. It cannot go beyond, below 0. That's why we close that lower control line at 0. Therefore, the lower control line is taken as 0. Upper control line, as we calculated, 0.14747 and the central line as 0.05. So we plot the points here. So this is the central line and this is the lower control line. 0.05 is plotted here and here this is at 0.147, and we know that all the points are within these two points, these two control lines. Therefore, see the process is therefore the process 0. See, one is the sample number 9 has a proportion above UCL, that is 0.147. Here some change in the location of this UCL, LCL and CL. That CL has to come with this point. So I shall uh, draw that this LCL should come at this point and UCL should come at 1.147, that is below this, just below 0.15. So we found that this sample number or subgroup number 9, the proportion is beyond the control line. Therefore, we say the process is out of control. So here we note that there is some error in drawing the central line and also the upper control line, and the lower control line is as such 0 itself, and so this has to be deleted. That's a mistake, and this is also has to draw here, means 0.05. So that's about the control chart based upon proportion. So the next question, and again a manufacturing process, number of defectives found in an inspection of 15 samples of 100 items. So we have all these samples have same number of items. So number of samples is equal to 15. Now the sample proportions are calculated. Then P bar is taken. P bar is equal to 140 divided by 1500 because 15 subgroups and each subgroup has 100 items. So 140 by 1500, and therefore Q bar is 0.9067, and therefore UCL and LCL are computed using the same equations, and we have 0.1806 and 0.006. And here we note that all these sample proportions lie within 0.1806 and 0.006. Therefore, here we say that the process is under control. The next control chart is NP chart or D chart. Here we make use of number of defectives in each subgroup, not the proportion of defectives of each subgroup, number of defectives in each subgroup. So here also we calculate the Pi di by Ni and Np and here N must be same for all the subgroups, and P bar is sigma di by I is equal to 1 to k di by Nk. N is the number of items in each subgroup and k is the total number of subgroup, and here this UCL and LCL are given by Np bar plus 3 root of Np bar into 1 minus P bar and Np bar minus 3 root of Np bar into 1 minus P bar respectively. And this is also formulated from the same principle of the relation connecting normal distribution and binomial distribution. Here we note that x minus np by root npq follows n01. X follows actually binomial distribution, but when n tends to infinity, x minus np by root npq follows n01. Or we can consider x as normal distribution with np and root of npq, and we get the above this equation x minus np by root npq when we subtract mean from x and divide by standard deviation. So here we count number of defectives, but in other case we are counting proportion of defectives. But the principle of constructing the control limits, control lines are actually based upon this relation connecting standard normal and also binomial distribution. That's why we have the central lines and control line. Central lines, no, upper control line and lower control line as np bar plus 3 root of np bar into 1 minus p bar and np bar minus 3 root of np bar into 1 minus p bar. That my scalar multiplication of 3 is to get the standard model mu plus or minus 3 sigma and mu plus or minus 3 sigma, that is 3 sigma limits. So that is about the construction of control lines based upon a number of defectives or NP chart. This is an example of this NP chart. Here we have 10 samples and number of defectives in the 10 samples are listed in the second row. So here P bar is equal to some number of defectives, that is sigma di 200 and k, n is 200 and k is 100. N is the number of items in each subgroup. So therefore it is NP bar, that is 200 into 0.1, 20. So 20 is the central line, that is NP bar. NP bar is 200 into 0.01. N is the number of items in each subgroup and K is the total number of subgroups. That's why it is 20. Now UCL and LCL are given by this equation. We substitute the values and we find that the item number 3, the number of defectives in the above UCL, is beyond the limits. For item number 3 we get 42 defectives. Okay, 42 defectives, but the control lines are at 32 and 7. So this is a point where the number of defectives goes beyond the limits offered by UCL and LCL. Therefore, we say the process is out of control. There is a second example, again with 20 subgroups, and in each subgroup there are 100 items, and therefore we have the proportion of each subgroup by di by ni, and here ni's are equal, so it is equal to n or 100. So p bar is sigma is equal to 1 to k di by nk, and we can note that is 200 by then 100 into 10, that is zero point 0.1. P bar is equal to 0.1. The central line is therefore n p bar, that is 100 into 0.1, which is 10. Now the UCL and LCL are computed based upon the same equation. So we get the UCL as 19 and LCL as 1. Here the number of defectives in all lots lie within UCL and LCL. We can note that these 10, 12, 14, etc. up to 9, all values lie within 1 and 19. Therefore the process is under control. Now, choice between when to choose P chart, when to choose P chart, and when to choose NP chart. If all the sample sizes or subgroup sizes are equal, we can take NP chart, and if they are unequal, we can take P chart. Now next is C chart. The C chart is based upon number of defects. So number of defects in a unit area, say unit area means 1 meter length of the product or 1 meter square area of the product, etc. So we count the number of defects occurring in this unit space, unit length or unit area, etc. And that's given by this C chart. So here the central line is C bar. C bar is number of defects in all samples divided by number of samples. That is C bar. And UCL is given by C bar plus 3 root C bar, and LCL is given by C bar minus 3 root C bar. So the difference between the P chart and P chart with C chart is, in P chart or NP chart, we are depending on the proportion of defectives or number of defectives. But here we are counting, in C chart we are counting the number of defects in a unit area. Not we are classifying according to the status of the item. We are just counting the number of defects in a unit area. So these are the upper control line and lower control line. Now we have one example showing the construction of C chart. Here we are given 10, not 10, 20 subgroups, and the number of defects observed in each subgroup is recorded, and therefore here it is C bar 275 by 20, 13.75. So this is the central line, and upper control line and lower control line are determined according to the equation C bar plus 3 root C bar and C bar minus 3 root C bar. So we get they are 24.87 and 2.63. Here we note that this lot number 14, there are 25 items. Okay, 25 defects. Okay, lot number 14, there are 25 defects. So we found that the process is out of control. So another example again to construct a C chart. Here we have 10 subgroups, and number of defects in the 10 subgroups are given in the second table, and C bar equal to 30 by 3. That is, the central line is at 3, and the upper control line, lower control line are determined according to this equation, and it is 8.1961, and the second is LCL minus 2.19. Here also we note that this LCL cannot go below 0. Therefore, we have to take it as 0 because this is the number of defects based control chart. So it cannot go below 0. So it is taken as 0. Now we know that all the number of defects lie between 0 and 8.1961. Therefore, we say that the process is under control. So that's about the construction of C chart.